Afternoon, here are some additional notes to go with chapter 11. I'm going to set you an assignment based on these notes tomorrow, so watch and listen carefully. So first of all, we're going to look at establishing system requirements and how a system analysis would go about that, establishing system requirements for a problem that's been set. And first of all, what the analyst must establish is the origins, the uses, volumes and characteristics of the data about the problem, the project, what they're going to do. They then have to look at procedures, what is currently done. So what's currently done, where is it done, when is it done, how is it done? And if there's errors in the system, how are errors handled? What happens when an error occurs currently? And exceptions are handled. So that's when the system is processing, data's flung up that is an exception to the rule or seems to be an error. How are those exceptions handled as well? So you look at the current system, the current procedures, you look at the data, where does the data come from, how much data has been processed, what type of data has gone through the system. Then you look at the future. So what are the development plans for the organisation that you're putting this project or solving this problem for? What are their plans? What are the growth rates? Is this a system that will grow over time, will have more data going through it? Is it expandable using what you're going to put in place? So you need to know that is a scope for developing the system in future. Problems with the existing system. So you could do that by looking at the system yourself. You could do that by asking users of the existing system. So what problems are there with maybe user interfaces or output or how things are done. So find out problems with the existing system. And the idea with your new system is you're obviously going to try and get rid of those problems that exist. Okay, so looking at the types of approaches you can have with software development. So when you're looking at very system analysis methods, one method you can use is the prototyping or the Agile approach. What this involves is the stages of development are not in a linear sequence, unlike the Waterfall approach. It's not a linear sequence in this approach. There is some analysis and design done. Then you design and implement, and then you get feedback from the user. So you put in parts of the system, put it in place, implement it, then get feedback from the user as you go through the system. So you don't do the entire system, you do it parts at a time and get feedback from the user at those stages. So any incremental changes are made in response to feedback. So if you get feedback from your user, you then put those changes in place as you go through, as you develop the prototype, as you develop the system. Other parts of the system are being analysed and designed as you're developing bits of the system that can be developed. Maybe you're analysing and designing other aspects of the system at the same time. The iterative process, it continues until the finished system is what the user wants. So you can keep in that cycle of design, implement, feedback from the user, do it for each part of the system, and it's only when you've got the feedback from the user on the finished system that the system is stopped. Advantages of doing this system, of prototyping of the Agile approach: the user is involved at every stage of the system, so not just at the start and then you give them the system at the end to test. They're involved at every stage of process, so you're getting that feedback from them. So therefore the model should develop better because both the user and your development team, whoever's putting the project in place, understand the requirements better at each stage. It allows for changes as you go. As requirements are considered in more detail at each stage. So it does allow for stages. That's where the Agile approach comes in, being able to change as you go through. The user involvement will mean that you're more likely to get the system that the user wants, because if you involve the user throughout each stage and you're getting feedback from that user and what you're developing, then you're more likely to get the system that they want in the end. Another method of systems analysis is the Waterfall model. The Waterfall model involves, in each stage of analysis, design, implementation, evaluation has to be completed before you start the next stage. So you do the analysis, you complete the analysis, then you work on the design. Complete the design, then you implement the system. Once the system's implemented, you then get the evaluation. So each stage is completed before the next one has begun. An advantage of that system, it's more suitable for smaller, simple, well-defined projects. Usually if it's a quicker project, a project that's not going to take too long to do, if it's got to be completed quickly, then that's a good method to do it. But as long as your design is clearly stated and understood before you start the design and development. A disadvantage of the waterfall system is it has very little user involvement. So the requirements, if you don't understand the requirements of the system, the finished system might not be what the user wanted because you've not got their feedback as you've gone through and developed the system. Usually you find the waterfall system is used, it's suitable for small projects, simple projects, well-defined projects that are quickly completed. So that's usually where it's best to use the waterfall system there. Looking at the next one, the spiral model. In the spiral model, the requirements of the user are defined at the start and a prototype is built. At each stage, the stages of analysis, design, implementation and evaluation are carried out for each prototype that's built. So you analyse, you design, you implement, you evaluate each prototype as you build. The process continues until the full system is completed satisfactorily. An advantage of the spiral model is the user is involved. The user can see the prototype at each stage and see where the project is going. So they get an idea as you're going through the project what the end product might look like or what parts of it will look like, and they can feed back on that. A disadvantage of this project is it might never be completed if it's a long project and you're constantly making changes to the system, then actually might never be put in place. You're only working and developing on prototypes and continuing to improve the prototypes, but never actually putting a system in place. That can be a danger of the spiral model. The best usage of the spiral module is for large-scale projects that might take many years to develop, because as requirements change or as technology changes as you go through the project, the spiral model allows you to develop and adapt to that new technology as you go through the project. The other system analysis you can put in place is rapid application development. Again, suitable for large projects. You have workshops and focus groups to get information from your users on the current system in place or what they'd like the system to look like. So you work that way rather than doing a more formal systems analysis document. Prototyping is also part of rapid application development. You use it to refine your system, get feedback from the user, but you have a strict time frame in which you try and create each part of the system. An advantage of RAD is developers avoid getting sidetracked by suggested improvements. So you produce the system that people are satisfied in within a time frame. So rapid application development is good when you're working to a deadline and a time frame. A drawback, again, is the system might be a compromise. So it's not a perfect system, it's not the ideal system, but it's a system that does the job, and it did the job in time for the deadline. But it might not be the system as it best could be, but it's a system that meets a deadline. So that's a drawback of rapid application development. And again, it's good on larger projects that might take a long time to deliver, because you get prototypes and working systems in place before the end of the full project. And it allows you to develop the system then at a later stage. Finally, a little bit on black box and white box testing. Black box testing is carried out independently of the code used in the program. It involves looking at the program specs, creating a set of test data that covers all input, all output, and all program functions. White box testing is dependent on the code logic, so it derives from the program structure rather than the function. The program code is studied, tested, devised which test each possible path at least once. A weakness of white box testing is it will not detect missing functions in your testing system. Okay, so there are some notes, some additional commentary from me. Have a look through those notes, have a look through the chapter, and I'll set you an assignment to do based on the chapter notes tomorrow.